Hello, this is Christian Idealism, and today I'm going to be explaining in this video what is Bayesian confirmation theory. So I've talked about Bayesian confirmation theory a lot on this channel, but I thought it would be nice to actually get down to the basics of it. So Bayesian confirmation theory is let's just say a theory about scientific confirmation. So of course there are different theories about how scientific confirmation works. Another rival theory is what's called likelihoodism. And then you got likelihoodism, Bayesianism, which is what I'm going to discuss in this video, and you got what's called hypothetical deductivism. So I'll do separate videos on those probably at a later date. But here I want to explain what Bayesian confirmation theory is, because this is very specific. So Bayesian confirmation theory is basically the idea that you can calculate the probability of your hypothesis conditional on some evidence. So how does this work? Well, there's a famous formula for this, and I'm not going to show you guys what it is. I'll just kind of describe it. So basically, this is what the theorem is. You have the probability, so you have P, and then H, conditional on E, is going to be equal, okay, so bear in mind, so it's a theorem, is equal to the probability of E, conditional on H, times the probability of H, and then divided by E, okay? That's what's called the simple form of Bayes' theorem. Now, of course, there's other forms out there. So the one that sorry, my brother's trying to get ice cream right now. But anyways, so let me explain. So there's also different forms of Bayes' theorem out there. Like I prefer for myself the odds form. So you have the probability of H conditional on E and K equal the probability of H conditional on K, or sorry, yeah, probability E conditional on H times the probability of H and K, and then there's like, basically then you draw this line and then you do the negation of the hypothesis at the bottom. Not this very technical, it's kind of hard to explain in a video, but yeah, that's the basic gist of it. And specifically Bayesian confirmation theory is probably one of the mainstream views of confirmation within the philosophy of science, and there's been a lot of work done for the past, I would say, 50 years just on this one theory, because there's actually different forms of conditionalization. So the two main forms, again, the one that I just described is standard conditionalization, but then you have what's called Jeffrey conditionalization, which I'll do probably a different video on that at a later time. But yeah, so on Bayesian confirmation theory, the important thing to keep in mind is that typically most Bayesians, I should say, hold to this view of evidence. It's called the positive relevance thesis. So what is the positive relevance thesis? Well, the positive relevance thesis just says that E is evidence for H, or evidence is, so you talk about evidence is evidence for H if and only if the probability of H given that evidence is more likely than without that evidence. That's the simplest way to put it. Now, of course, there's different ways you can describe the positive relevance view of evidence, but typically that's just the basic idea, right? The other thing too with Bayesian confirmation theory is that it does not really matter what field you're really talking about. So the interesting part about it is that it applies to all propositions, right? So it's not just about scientific propositions. There's nothing exclusively scientific about Bayesian confirmation theory. Rather, you can literally apply it to any propositions whatsoever. It doesn't matter what your propositions are. As long as there's evidence involved, as long as you have a hypothesis and an evidence involved, you're always going to be able to use Bayes' theorem as a way to calculate probabilities that way, right? Now, so that's the important thing to keep in mind. The other thing too is that typically within Bayesian confirmation theory, there's also this notion of Bayesian updating. There's notions of what's called Bayesian networks, right? So you have different propositions that relate with one another, right? And then you update probabilities based on new data you collect. That's more technical, and I'm not going to explain that in this video. But there's more sophisticated accounts of exactly how that works, especially when we're dealing with let's say in a scientific context. So typically a scientific theory is going to have a whole list of different propositions, And then those propositions are typically going to be supported by different lines of pieces of evidence. And so you can actually model, epistemically, you can literally model scientific theories just based on Bayesian networks, right? There's been a lot of literature just written on that. And so the interesting part about Bayesian confirmation theory is that basically, I think that's basically how science works. I think that when we're talking about whether a scientific theory is more likely than not or less likely than some other, whenever we're doing comparisons, I think ultimately we're using Bayesian confirmation theory as a way to filter these out. In fact, I think all of the quote unquote theoretical virtues that people like to talk about, so like simplicity, explanatory power, those kind of things, right? I think, oh yeah, and then of course rational coherence, right? I think like anything to do with theoretical virtues are really just going to be boiled down to Bayesian confirmation, right? I think you can model that explicitly in probabilities just based on Bayesian confirmation theory, right? So I think science itself, the epistemology of science, is Bayesian confirmation theory on my account, right? Or at least that's kind of my understanding. And then you just apply that, this Bayesian confirmation theory understanding, and you just apply it to any propositions whatsoever. And so really the epistemology of science is the same across any amount of propositions that we can talk about. Right? That's the important thing. And that's the really cool thing about Bayesian confirmation theory, is that it's not strictly confined to this notion of, I should only believe in what science says. No, you should, more accurately, you should say, no, I should believe in whatever the evidence supports, right? That's the idea, right? That's the idea. So definitely Bayesian confirmation theory is a big part of what's called evidentialism, which is there's a whole literature on that, which I'm not going to get into in this video. But yeah, hopefully now you kind of understand at least the basics of Bayesian confirmation theory. So yeah, and then one last thing I just want to mention, which is that there are two kind of ways of understanding exactly what Bayesian confirmation theory is trying to get at. One consideration or one kind of interpretation is what's called this degrees of support view, which is typically the mainstream view. But then you have this other kind of understanding of Bayesian confirmation theory, which is this idea of I think it's degrees of support, right? So degrees of support. So you have degrees of belief and then degrees of support. Now, degrees of support basically says, I could be wrong. I might be butchering a little bit, but basically, on the view of degrees of support, you would say that the epistemic probability or an epistemic probability is basically epistemic support relations between propositions. And so when you look at this from a Bayesian lens, you say, okay, here's one proposition which is my hypothesis. And then you have this other proposition, which is a description of our evidence. And then we ask, okay, how well does this evidence support my hypothesis, right? And so you can logically show, hey, here's this one proposition over here, which is my evidence, and this proposition is more likely conditional on my other proposition, which is my hypothesis, right? So that's the E conditional on H, right? That's just the likelihood ratio. And then you just times that by the probability of the proposition itself. So in this case, the hypothesis. And then divide that by E, right? And then you get the posterior probability, which is the probability of the hypothesis, which is the proposition of the hypothesis, conditional on that evidence, right? And you could just keep doing this, right? So Bayesian update, you just, as you gather more and more evidence, you can always add more propositions, which is, your different degrees of support to increase the probability of your main hypothesis, right? So that's the idea behind Bayesian confirmation theory. One final thing when it comes to Bayesian confirmation theory is that there's a difference between Bayesian confirmation in an epistemic sense versus in a statistical or set theoretic sense. So in one sense, you can use Bayesian confirmation theory in a statistical, context. So for example, like when you're doing set theory or something like that, you're going to be using Bayes, right? But when it comes to epistemology, so when it comes to Bayesian epistemology specifically, we're talking about propositions and not sets. So that's an important distinction to also draw, which is that when it comes to Bayesian confirmation theory within a philosophical context, within an epistemic or philosophy of science context, we're talking about propositions. We're not talking about sets. So that's the important thing to also keep in mind when it comes to Bayesian confirmation theory. So yeah, that's pretty much it. There's more I can get into. There's more in the philosophy of science because, again, I specialize in the philosophy of science as my undergraduate, so that's what I study. And specifically, I specialize in, that's what I'm studying as my undergrad, just Bayesian confirmation theory in general. So yeah, hopefully this is a good kind of intro to Bayesian confirmation and how it works. I could get more into the nitty-gritty details, but I'll save that for a different video. Anyways, thank you guys for watching and listening, and have a nice day.